Hi everybody. This video is going to cover failures. I had a couple of emails where people were asking me to share some of the darker times I've had in my designs and when I'm, putting together what aircraft I'm going to design and the systems that go into it. And the other day I had a pal on Facebook send through and basically say, Damien, can you share what you would have done different or what you learned from the B-36 or what you have learned or would have done different on the C-130? So what I've decided to do is talk about the B-36 first. When I first designed the B-36, it was going to have a 30-foot wingspan. It's going to just be a big, totally built-up balsa wood floater. Almost like a cartoon plane because it would have been so big it wouldn't have been very scale. However, when I got into the AutoCAD and I started designing all the formers, all the stringers, I had so much data that I knew I could build a very scale airplane. So the 30-foot plane, I investigated, how big the propellers would have to be. And they would have had to been close to 28 inches, which means they would have had to been gear driven. So I reached out to a couple of manufacturers that did some gear reduction systems, and they were jerks to me because they're like, you're never going to build the airplane. And they really were. I mean, as manufacturers, they were jerks. They just thought I was a nobody. I've never won Top Gun. I've never... sorry about that. This late, I'm surprised somebody's calling me. And I'll call him back later. And so... It was really depressing how many manufacturers I reached out to. I've never been in the Scale Masters. I've never competed in Top Gun. I'm not that kind of a builder. I just like to build airplanes that have massive systems, but they're not really 100% scale. So I designed my very first wing on the B-36 with the assumption I was going to have drive shafts to keep the motors ahead of the center of gravity. Because 6 of those motors weighed quite a bit in the airplane. And I tested it, and my self-confidence just wasn't good enough in my design capabilities because even though the systems tested out and everything was great on it, I was just paranoid that I'd get this airplane built over a 2 to 3 year process. And then in the end, I would have shafts in the wing that didn't work. So my mistake was not trusting my design. I should have stayed with that. So I redesigned another wing that was Wing 1.0. If you remember 10 years ago, everybody was following me when I first started designing the airplane. I called it Wing 1.0. Then Wing 2.0 had the motors at the trailing edge of the wing. And I had worked with a manufacturer on designing landing gear for it. And they ended up being completely a waste of my time and cost me about $1,500. They said, no, we have standard air cylinders, we have standard gear, I'll go right into your plane, it's no big deal. I said, okay, how much is it going to cost? They quoted me. 6 months later, I sent them my CAD drawings and said, okay, I need that landing gear now because, I can't afford everything at one time. Well, they said, well, our system won't work for you. We need to custom build you one. The one they built ended up just being stupid heavy. It didn't have any up locks or down locks. It was just using air pressure to hold the gear. And it wouldn't fit in my wing. And I had to redesign another wing, so I went to wing 3.0. And on wing 3.0, it was going to be pusher motors, the motors in the nacelles on the trailing edge. And the landing gear, they ended up weighing almost 20% of the entire airplane's weight. It was really crazy. That entire airframe with nothing in it only weighed 26 pounds. My landing gear weighed 21 pounds. It was insane. So, and then on the nose gear, it was just a complete Rube Goldberg mess. So I already started getting very frustrated with B-36 because I had already at that time spent like 5 years on it. And then when I sandbag tested the wings, they deflected a little bit too much. And that was kind of like the... straw that broke the camel's back for me because I do not want to fly a 120-pound airplane around people that could have a flap jam, which basically becomes an aileron, and just have an unsafe airplane or a maintenance pig, which is kind of an oxymoron because this plane is going to be a maintenance pig. The prop system I should have stayed with. I should have built my own landing gear for it and trusted my own design capabilities. When you're doing projects on the scale that I do, you have to have the best of the best team working with you. You can't have rookies. You can't have people saying, "Oh, I'm sure I can figure it out for you." You need to really work with people that are going to get on the same level as you, that you're going to do it. So my mistakes with the B-36 was moving from any of my original designs. I should have stayed with my original designs. The flaps, because of the way the wing would flex, wasn't designed quite right. They were very cool the way I designed it, but they just didn't work. And then the wing testing and safety is the biggest reason that I scrapped it. Now, I was lucky enough, there's a guy going to be building a bar, and he bought the whole airframe because he wants to hang it on the ceiling, and it helped pay for this airplane because for the last 2 years, money's been really, really tight for me. I've got a girls' college I've put so much money toward, and my family and all those other things, so we're not starving. It's just my hobby starving the last 2 years. The C-130. When I first designed this, I had no idea how thick to make the fiberglass on my reverse mold. So my mistake on the C-130 so far is I put the glass way too thick, which means with all the formers I had in the airplane, they became pretty useless. So I ended up taking out every former in the fuselage and putting a few select carbon fiber formers in. Took 2 pounds of weight out of the airplane, but still, if I would have used 2 layers less of glass cloth on the fuselage, the plane probably would be a pound lighter. Wing design, I ended up building a heavy wing again. I cut out styrofoam, hot wire the styrofoam, covered it in balsa wood, covered it in fiberglass. I have plywood ribs inside that foam for the hard points, which were the flap hard points, the motor hard points, and where the ESCs attached to the motor is even more beefed up right there. So in hindsight, I should have built the wing like I did, but made a mold out of it and used fiberglass and carbon fiber with select carbon fiber ribs, and I would have been able to build those things extremely light and extremely strong. But I learned from that. If I had the money, I'd build 2 of everything, because everything I learned from the first one, I could have done on the set. I would do much better on the second one. This is 160 inches. I am going to build a second C-130 before I die. It's going to be 240 inches like the original design. It's going to be the Spectre gunship. It's going to have the guns hanging out the side, fake guns. It will have reversible props. I've designed a system that I know will work. Well, actually, there was a really nice, I think, Italian gentleman that designed it originally. I modified his design for the C-130, and I know I can make the reversing props. It's just expensive to do all the R&D on it, and I need to get my Hacker motors or whatever motors I'm going to use and find hollow shafts, because you have to have a hollow shaft, at least in my design, to have reversible props. Main gear is still heavy. I use stainless steel in a lot of the parts, and they're going to come out and be a high strength aluminum before the plane flies. I wish earlier on I would have trusted my instincts and built it all out of aluminum, because that's what I started with, but I got paranoid and put steel in there. Steel's not needed on most model airplanes. Nose gear mechanism. It's extremely, extremely complicated if you looked at all the linkages and everything I've done. If I had to do it again, I probably would have used some servos in there instead of making everything mechanical like the doors. It is built really strong, though. There's no reason it shouldn't work. It's just something I would have redesigned. The flap design I would have done a little bit different. I would have had beefier servos, and I would have had a lot more nylon in there, so it would be easier for things to move on the tracks. And the rear ramp is just a fat pig. It weighs so much that it really upsets me. I've rebuilt it 3 times, and for it to have it, keep in mind, when the sleds or whatever I'm dropping out the back of the C-130, there's going to be enormous forces put on that on that ramp. So anything that's sliding out the back of there has to exit the aircraft, because if it jams, it could bring the airplane down. So there's a teeter-totter there. I've got to build it as light as I can, but I still have to have it stronger than a brick house to make sure that it doesn't deform or jam as my pallets or sleds are sliding out of the airplane. It may just be me, but every time I pick it up, I'm like, damn, this thing is heavy. So in the C-130, that's the things I would have changed the most is I would have done the wings differently. I would have done the fuselage differently. I would do that rear ramp a little differently. And the landing gear I'm still going to modify to make lighter. So there's a lot of things on the C-130 I would have done. One thing that I'm starting to learn to do, and as I get older, or maybe I need to be on meds, I don't know what it is. I used to love to design and draw everything in the CAD and the 3D. And now I'm more interested in the build. I actually get a lot more out of this when I'm building and creating than doing it in the design. I already have 5 or 6 aircraft already designed that I want to build. But right now, designing for me in CAD is just really hard for me to dedicate the time. And you have to do it because every moment you spend in CAD designing it and figuring out how it's all going to work is going to make it so much easier when you go to build the real airplane. And it's going to be a lot less money. Because I tell you, there's so many times that I have built prototype stuff because I just had the idea or the vision to do it. And I didn't go and do it good in CAD first. And then I go back in CAD and figure out how parts fit. So I really did it backwards. So just make sure if you're really going to design this stuff, get 99% of the design done in CAD and 3D, and then move into the prototyping or whatever stage you want. Now, one thing I want to touch on when we talk about failures, because there's a lot of people that hate to use the word failure. And I hear people say sometimes in meetings like, well, I like to fail because I learned from it. That's BS. Nobody likes to fail. But if we learn from failing, if we truly understand why we failed, if you can really, truly understand what went wrong there, and then you come up with your basically action plan on how, okay, I'm going to make it better or I'm going to move around that, then you truly have success. Most people will do the same thing over and over again and not go outside the box. And I hate that phrase, working outside the box. I mean, anybody who's a designer works outside the box. But I guess what I'm trying to say is that, there's so many people that used to be kit builders when I was young because there were no ARFs. The almost ready to fly airplane didn't exist. And when they first came out, a lot of us hated them because they were basically just a monocoque bag holding together all the wood because nobody glued anything right together. Nowadays, there are some really good ARFs out there that are absolutely beautiful. But still, the builder is disappearing. There's very few people. It's hard to buy kits right now. So a guy like me who would never build a kit because they don't make this size C-130 in a kit, it gets really hard. And, to build the kind of aircraft you want. So I guess what I'm really trying to say here is that don't ever be afraid of the failure. There was that old phrase, how do you get to Carnegie Hall? Practice. And it's true. My daughter plays a clarinet. Sometimes she gets upset when she's not first chair every time. And honestly, she doesn't practice that much. She's just really good at it. I told her, if you practice all the time, but she's like I am. If she practices all the time, then she's missing out on other things she would be doing that was fun. So failures, you're going to fail, okay? Now, the next plane I'm going to build is a Embraer 175. And the reason I'm building that airplane is it's going to have ducted fans. If you remember back in the 80s, they came out with the unducted fan. And that was the 737 that had the big blades on the back of the jet engine because a high bypass engine is much more efficient than a low bypass. High bypass meaning that you're moving all the air around the outside of the core jet engine and you're using it with propellers. And those blades, the bigger diameter anything is, the more efficient it's going to be. That's the reason you see the jet engines nowadays getting to be massive, because the bigger those fans are, the more efficient they are. Well, the same is true with the model aircraft. I need to have a 12 to a 14-inch fan with 18 carbon fiber blades, and it's going to look exactly like a scale jet engine, high bypass jet engine. I need to turn it around 4,000 RPM, I believe, to get the thrust I want. But I'm going to build that engine before I design any part of the aircraft. Because if I can't build those two engines and get the thrust I want out of them, I'm not going to spend all that needless time on that big jet. And it's going to be big. It's going to be about a 200-inch wingspan or 190-inch wingspan. So it's going to be the Embraer 175. It looks kind of like a midget 737. It's going to have the very large ducted fans. The entire fuselage is going to be carbon fiber with some carbon fiber bulkheads. The wing will be fiberglass with carbon fiber reinforced with carbon fiber ribs. And but I want to tell you how I get to this, and it really is the team I have around me. I mean, you've all heard me talk about Berger. You know, he and a guy named Dean helped develop those wire keep things that I use all the time, and I don't shoot. I got everything laying around right now. And I just put them in the airplane. I just glued a bunch in the airplane, and if I didn't have my microphone, I'd get them for you. But these wire keep things are the styrofoam things that hold your wires. They're fantastic. Dan Landis, who's with Hobbyco and Futaba, has made this project so much lighter and so much efficient with the Futaba S-Bus system. I'm going to do a whole video on it, and it's going to be kind of hard because it's hard to get the camera into the airplane and move around. So it might be kind of a cheesy video I make, but I'm going to walk you through a lot of stuff I'm doing with this S-Bus system. Because if you're building large-scale aircraft, there is no system, in my opinion, right now that gives you the flexibility and the coolness of being able to basically put a data cable through your airplane, and you can plug in your telemetry wherever you want, you can plug in the servos wherever you want. There's nothing like this that I've been around yet. Maybe somebody else has something that they're trying to copy. Because one of the things I notice about Futaba is everybody tries to copy Futaba. So, and then I've got all my other people on my Facebook that email me that certain things they do with composites and all that stuff. So I've been really lucky that I've gotten a really good team around me of experts, and that takes my failure rate down. But all of us know, and we laugh about it. Very rarely does anybody get upset when we fail, especially when you're doing this kind of stuff. I've got some friends that I'm always on FaceTime with, and we're always laughing about breaking stuff, or we keep waiting for my prop testing for a propeller to explode, and they just haven't, which is good. But I mean what I'm trying to say is if I design a propeller for 4,000 RPM, I'll take it up to 7,000 RPM for about 15 to 20 minutes. I mean, not at one time, the batteries won't last that long, but I'll put that much time on it at 7,000 or 8,000 RPM to make sure that the blades just won't blow up. And it's scary. I get out of the room, I'm doing it from a different radio, and I just hear it running its butt off in here. And, if it explodes, we're going to laugh about it because we'll know I got to go back and figure out why it blew up. So don't ever take your failures that seriously. Sure, we get depressed. We get, you got to get over it. There's going to be that healing time. But you're going to fail if you really want to do this kind of stuff. For every really cool success I've had like this, I bet there's been 20 failures or more. So that's pretty much all I wanted to talk about. I do have another video coming up soon, and somebody emailed me and said, Damon, can you expand on your custom landing gears and custom all this? First of all, I hate the word custom. And this video I'm going to make will tell you why I hate the word custom. Because to me, we're always spec building. Okay, if you know that somebody wants to build honeycomb like this, you're not going to build it without a specification that's going to talk about the type of skin, the type of core, the type of adhesives. You're not going to do anything, because if you do, you're just wasting your time. So you should everything in aviation, everything in aerospace I've seen is basically spec built. You don't call anything custom. If you're going to customize your car, you're going to put custom pinstripe down the side. Sure, you customize your car. Or if you're going to take your golf clubs and put some little gold rings on them, sure, you customize them. You customize that. But anytime we're building something that has a true need, we're spec building it. The reason you want to understand the difference is if you have a true specification, you should off that specification be able to cost exactly what this is going to be. But if somebody doesn't tell you how strong this needs to be, they might overbuild it. That adds cost. That takes down on performance. Because a lot of people don't realize that heavier... There was one time a Russian rocket that was going to go into orbit, and the scientists had used a different fuel tank for the liquid oxygen, I think it was. And they put an extra, like 2% of fuel in there because they just thought, we might need it. Now, this was back in the 50s and 60s when they were first going into space, but they didn't understand that extra fuel added weight to the rocket. That engine was going to only burn, because back then they had timers that told exactly what the telemetry was going to do and how long that engine would burn to get to the delta between standing still and being in orbit. And by them topping off that fuel tank thinking, oh, we're going to add a little bit extra fuel, they added weight to the rocket and it didn't achieve orbit. I'm sure in Russia they executed those two guys. But keep in mind, if you're going to do something, you have to have the spec to know you're doing it, or you're going to overbuild it, underbuild it. You're going to spend too much money, or you'll have something nobody wants. So with that said, thanks for watching my videos, everybody. I hope you have a great night. It's still not quite midnight. And if you got any questions at all, let me know, and have a great day. Make sure you can email me through my YouTube or through my Facebook, and keep the questions coming. Thanks a lot, everybody. Have a wonderful day or evening.